Hello class, in today's video we're going to be adding and subtracting algebraic fractions. The learning intention of this video is we're going to know how to find the lowest common denominator of algebraic fractions. We're going to be able to combine numerators using expansion and addition of like terms, and we're going to be able to add and subtract algebraic fractions. So how do we actually do this? Well, based on your prior knowledge, you would have already knew that fractions can only be added or subtracted when the denominators are the same. And when the denominator is the same, all you really need to do is you just add or subtract the numerators together whilst keeping the denominators the same. And this is illustrated in these two examples down below. So my very first example over here, you've got 2/5 plus 1/5. Now, if you were to do this, you'd keep the denominators the same. And in this case, the operator is the addition sign. So you add them together, therefore your answer is 3 and 5. In my next example over here, I've got literal letters, okay, so I don't really have any numbers at all, but in this case, it's got the same denominator, so being D. So all you need to do is just collect the like terms together. In this case, A and B aren't like terms, so the best way you could simplify it is just writing A minus B. Now, most of the time, you're going to encounter questions where you're not going to see fractions with the exact same denominator. And what you need to do in these types of situations is you would need to either convert one of the fractions or both of the fractions so that they can actually share the exact same lowest common denominator, also referred to as the lowest common multiple, okay? And I'm going to use the example down below to kind of illustrate this. So I've got 3/4 plus 2/3, and we can clearly see that they both have different denominators, okay? So what we need to do in order to add them together is we need to identify what is the lowest common multiple. In this case over here, what I'm going to be doing is I'm going to list down the multiples of 4 and 3. So I just go 4 times 1, 4 times 2, etc., etc. And in this case over here, we can see that they both share a common multiple, which is 12. And this is the lowest common multiple that they both share. So in this case over here, once you've identified the lowest common multiple, what you need to do is that you need to ensure that this is now your new denominator. So in this case over here, if I want to change this to a 12, what I will need to do is I will need to multiply that by 3, because 3 times 4 gives you 12. But whatever I do to the bottom of the fraction, I must also do the same to the top of the fraction as well. Similarly, on the other fraction, in order to change this to a 12, I would need to multiply both of these two terms over here by 4. And if you did that, then you're going to get 9 on 12 plus 8 on 12. And therefore, since the denominator is the same, I can therefore add them together. So your answer is going to be 17 on 12, okay? Now, I've got another example here. So this is an algebraic fraction. Now, as you can see over here, the denominators aren't the same, so we can't just readily add the numerators together. What we need to do is identify the lowest common multiple. In this example over here, you can clearly see that the lowest common multiple is also 12. So in this case, because this is already 12, I won't change this, but I will change this denominator over here, okay? And I'll do that by multiplying both the numerator as well as the denominator by 3. And if I do that, now my expression is going to be 9x on 12 plus 5x on 12. And once we've got this exact same denominators, all we need to do therefore is add the numerators together. So therefore my answer is going to be 14x on 12, but this can be further simplified as 7x on 6, since 2 is divisible into 14x as well as 12, okay? So what I've just showed you on this particular slide is how we can actually add and subtract algebraic fractions by locating and finding the lowest common denominator. Another way that you could actually add and subtract algebraic fractions is by simply cross multiplying, and I'll show you through an example over here. So in this example over here, notice that you have these denominators over here that aren't the same, okay? So what you would do in order to make sure that they have the exact same denominator is that you just cross multiply. So in this case, I'm going to multiply this fraction over here by 13 for both the numerator and the denominator. And for this particular fraction over here, I'll multiply this by 7 for the numerator as well as the denominator. So if I do this, all I need to do is therefore find the product of these terms. So therefore 13 times 4a is equal to 52a, 2a times 7 is equal to 14a, denominator is equal to 91, and therefore I'll just simply add the numerators together, okay? So this particular strategy also works as well, particularly when there's not an obvious lowest common denominator, but you could obviously use the other strategy that I use, and that way is more preferable when there is a lowest common multiple or denominator that is readily obtained. So I'm going to show you another example over here. So in this case over here, we're going to follow the exact same steps. So we're going to see if you can find the lowest common denominator. In this case over here, you would agree with me that the lowest common multiple, the lowest common denominator is equal to 10. Since this is 10 already, I'm not going to touch this fraction over here, but I will convert this into a 10 by multiplying both the numerator as well as denominator by 2. Okay, so that's going to be my first step. So once I've done that, then this is what your new expression would look like. Okay, and now that the denominators are the same, I'm going to rewrite this as a single fraction. Okay, and watch how I do that. So this is how I actually make this into one single fraction, and once I've done that, I can therefore start expanding and collecting like terms. So once I've done that, therefore this is negative 2 times 2x, which therefore gives you negative 4x. Negative 2 multiplied by 3 gives you negative 6. Okay, so that's how I got this over here. Now, once I've done that, then I just need to simplify and collect the like terms. So therefore, x minus 4x gives you negative 3x minus 6. And in this case over here, you could either leave this as your answer, but also you would actually say that you can actually factorize your numerator. So therefore, if you were to factorize it, then this is what it would look like as your answer. But in this case, I would accept both answers. What I want you to do is I want you to have a go of answering this particular question over here. Give yourself 2 minutes and then compare your answers with my answers. If you guys have done this successfully, all right, the first thing you should have done is that you should have multiplied the fraction on the left-hand side by 2 and 2 to ensure that the denominators is the same, which in this case will be 6x. So if you do this, this is what your next step would look like. And now that my denominators are the same, I'm going to rewrite both of these fractions as one singular fraction. So if I do that, then this is what it would look like. And now what I want to do is I'm going to start expanding. So if I expand by using the distributive law, then this is what it would look like. And therefore, I'm going to collect the like terms. So 2x plus x gives you 3x, and 4 minus 3 gives you plus 1. So it's going to be 3x plus 1 over 6x. In this case over here, I can't simplify any further. So therefore, that's going to be my final answer. I now want you to have a go at answering these questions over here. So I've kind of already like halved the questions already. So you've already got a less workload to do. So please try not to complain about all the questions I'm giving you guys. So I want you to answer questions 2, 3, and 4, as well as 5. That's shown on this particular slide over here. But I'm going to show you an extra example before you can actually answer question 6, okay? And the question 6 is related to algebraic fractions with binomial denominators. Now, the word binomial, so this word over here, binomial just means 2 terms, okay? So therefore, a binomial denominator is a denominator that has 2 terms. So in this case, this is a binomial denominator because it's got x as a term and 3 as another term. And on the other fraction, you've got 3x as a term and 4 as a term, which is why that's also considered a binomial denominator. Now, when you've got these examples over here, the exact same principles still apply. So what we do in this case, when there's not an obvious lowest common multiple, well, all we do is we just cross multiply. So therefore, I'm going to cross multiply like so. And once I've done that, then this is what I'm going to get as my next step, okay? So this means 2 multiplied by all of this, which is what I've written like this, and 3 multiplied like that. Once I've done that, what I'm going to do is I'm going to rewrite this as a singular fraction, okay? So if I write this as a singular fraction, this is what I'm going to get. Now, I do want to stress that you do not mess with the denominator. Please do not try to expand. If you expand, it doesn't make things simpler at all. And at the moment, you haven't actually learned how to expand a binomial product. So please leave the denominator as it is. What I want to do next, as my next step, is I'm going to therefore start expanding my numerator, okay? So if I expand my numerator, it's going to look something similar to this. So therefore, when I collect my like terms, your answer is going to be 3x minus 1, all divided by 3x plus 4, x plus 3, okay? I want you to now have a go of answering this type of question. So give yourself 2 minutes and then compare your answer with my answer. So if you guys have done this successfully, what I'm going to do is I'm going to cross multiply. Therefore, I'm going to get this as my answer, start expanding and then simplifying so you can get your answer. And your answer should be x plus 18 all divided by x plus 2 divided by x minus 6. This is going to be the last question that I'm going to set for you guys. So I want you to have a go of answering all questions for question 6. If you have done this successfully, then you should be able to address both the success criteria in today's lesson. This is the end of today's video. Hopefully it helped you. I'll see you guys again in the next video. Bye.